Good afternoon to all of you. I'll be giving a brief presentation on a project called Delhi State Spatial Data Infrastructure Project, which will demonstrate how Delhi is gearing up and preparing itself in case of any disaster. And not only disaster, for security, for development, for planning purposes, you name anything, and this project is going to support activities of the Government of Delhi and other central agencies. This is a collaborative project which SecureIT has taken up with the Government of Delhi. The project comprises of creation of a urban information system, that is creation of a three-dimensional spatial data, survey from aerial photographs, then creation of a digital elevation model or digital terrain model, ground validation and overground utilities, 3D modeling of the city, that is texturing, visualization and creation of virtual walkthrough, mapping of all underground utilities, land information system, that is keeping information up to each and every parcel level, property survey, that is door-to-door survey of all kinds of settlements, buildings, their classification and their usage, then installing IP cameras, internet protocol cameras, then establishing 10 monitoring centers and 2 control centers, development of a geoportal through which all the departments of Government of Delhi and other central agencies will be accessing this information. The project is supposed to be completed in 4 phases. These are the 30 departments with whom we started interaction, and based on that this entire project was formulated. So you can see that all departments like MCD, DDA, NDMC, Revenue, Delhi Jal Board, Delhi Transco Limited, BCS, Rajdhani Electricity, Rajdhani, Yamuna, the NDPL, IGL, that Indraprasth Gas Limited, PWD, Department of Transport, TTC, Fire Service, Delhi Police, Election Commission, Education, Health and Family Welfare, Delhi Pollution Control, DTDC, the Trade Tourism Department, Census, DSSID, Irrigation and Flood Control, Department of Labor, Excise and Entertainment, Trade Tax, DIMS, that is Department of Integrated Modern Transport System, DMRC, Metro Rail, Commonwealth Games, Forest, DDMA, and some agencies we have not listed in this. We talked to all agencies and we really found out what is their requirement. Based on their requirement, we finalized that we need to capture 337 features. We are dealing with 28 kind of boundaries because every department has got its own administrative jurisdiction. We are dealing with 98 layers of building. We are going up to the gate, fence, even the hedge also. What to talk of the main building and the payment area, parking and other areas also. Dealing with 59 layers of transportation, utilities 64 layers, land use 40, and cadastre 5, hydrography 16, all riverine and water bodies, hypsography, that is the digital elevation model, image 3, framework 5, and input for updation, because we expect all the departments to carry out some activities and whatever new features are coming in, so they will be updated, but they will be kept as a separate layer. Then the 3D, that is texturing, visualization and rendering of all the objects. Then we carried out GPS survey, of course aerial images were used, ground validation, GPR survey for underground utilities and input by the line departments. Now the phase 1, which was basically to create framework and establish ground control points. We have used GPS, dual frequency GPS, and we achieved the accuracy of 5 centimeter for the overall network adjustment of Delhi. We have used digital photogrammetry technology. Aerial photography on 1:8000 scale has been used, and we achieved the accuracy of 12.5 centimeters. We have created a seamless digital terrain model or elevation model of the city with the accuracy of 50 centimeters. And we also have a seamless orthophoto image of 50 centimeter accuracy for entire Delhi. Phase B, which was basically to create a database schema, creation of a Delhi geoportal, and installing 63 wireless cameras, establishing 10 monitoring centers and 2 control centers, and capacity building for all the line departments, because whatever database is being generated is a high-end database, and people have to be trained to handle this kind of data set. Phase C, which is the primary data capture, which is basically the soul of the project, is that every object in Delhi has been mapped in 3 dimensions. That we have latitude, longitude and height, and each and every corner of the building has been mapped. that we have carried out ground validation because everything cannot be captured from aerial photographs. About 20% of the features they are not appearing. So that was captured using total station and other techniques using ground validation. And 2D map has been created and 3D map both have been created. Then for utility survey, we have used this mechanized TerraVision. This is for the first time that we have used this kind of machine in India and the fourth in the world. It has got 14 antennas are there. This is integrated with the GPS also. Its scan geometry is 5 inch by 1 inch and 14 antennas simultaneously scanning the earth. So practically every inch of Delhi has been scanned, and we have already completed this activity. A property survey that we are going from door to door, we are carrying out property survey. As per census 2001, there were supposed to be 27 lakh building units, but we have already covered more than 41 lakh and still about 25% of Delhi is still left. A land information system that there are 357 villages as per the 1996 Gazette notification issued by Government of Delhi, and we have made a seamless mosaic of all the Masawis, and the Khatoni data has also been integrated with that. This is just to show that how that door-to-door survey is being carried out. We have moved very systematically that each building has been given a unique ID, and its address has been captured, that it is falling in which district, which urban locality. There are number of urban bodies in Delhi, then rural locality, then type of settlement, which is approved planned colony, unauthorized regular colony, unauthorized colony. There are so many nomenclatures which are being used in Delhi, and we have tried to capture all. Then we have the plot and parcel number, the building, whether it is a multi-story building, then we have the building name, building address, and number of floors, below the ground, above the ground, and parking space. Once we move from within the multi-story building, then we have building units. So we have gone in usage and classification of each building unit, whether it is a residential, is a business, educational, health, institutional, utility center, religious, or government office, or a historical monument. Land information system, Delhi has got both the kinds of land information system, that is we have the rural cadastry and the urban cadastry. In case of rural, we have used existing government records, that Masawis, and Khasra, Khatoni data has been linked. They all have been scanned, georeferenced, vectorized, and made a seamless mosaic of the existing data. Now, how the value addition is being done by this project is that we are capturing the new parcel, because the earlier parcel information is there, this is of 1950s, and a lot of fragmentation and subdivision of the parcels has been done, that has not been captured and updated. So this is what we have done for Delhi also, that we have captured all the existing properties and incorporated into the land information system. So similar thing we have done for the urban cadastry also. We have collected all the colony layout maps from the MCD and other urban bodies, DDA, and same procedure has been followed, and all the properties have been mapped now. Now, this is one example that we have two Masawis, and the mosaic has been made, they have been vectorized, and Khatoni data has been attached with all the parcels. This is how the colony layout maps are being maintained by MCD and DDA. They have been taken from them, about 2,000 we have already taken. There are 2,500 regularized colonies, there are 1,500 unauthorized colonies, and leaving aside all the slum and other areas. This is how they have been georeferenced and vectorized. Now this is how that 2D map we have created. Now for texturing and visualization, this is the camera we have used. This camera is also integrated with the GPS. So whenever we click photograph of a building, it gives its latitude, longitude, position also, and the time of taking photographs. These are the two photographs which we have taken on ground, and this is the white model which comes from our digital photogrammetry technique. These photographs have been pasted, electronically stitched on the faces of the building, and this is how that in each building the model has been created, accurate to few centimeters. Now this activity we have done for most of the important buildings, public buildings, and religious building, monuments, and all buildings on the main roads. So this is how that we created 3D topology. That wireframe was done, the white solid model came from photogrammetry. The texturing has been done using photographs, actual photographs on the ground, and this is how the 3D visualization of the entire city has been created. Now, the view shed analysis, what happened in Bombay, the Taj, nobody had any idea that how to guard the Taj building. So now what we have created in Delhi, that anything happening, the people, security agencies can always see that which particular building from which point can be covered and how it is to be protected. So view shed analysis can be carried out. We used to hear about terrain, but now this is for urban area also. We have this kind of tools are available for agencies. And this is how that 3D mapping, that when we say that each and every object has been mapped in 3D, you name anything on ground which you see, that will be available on our map, whether it's a footpath, it's a light pole, it's a traffic light, it's a manhole. You can keep counting manholes on the road and keep walking, you will find out yes, map is accurate enough. And you can click on any building, you will find its attribute, that how many people are living in this area, who is the owner, who is occupant, when it was constructed. Now, this is one of the examples that how the DTM, that we have a few major drains. That Najafgarh drain is there. This is how that terrain has been used. In vector data has been draped on the terrain. That merging of Najafgarh drain with the Yamuna River. Now, how to use this data set? We have already created this database, and how to improve the governance of the various departments so that they can provide better citizen-centric services. So the entire database is on a secure network. This is the generic application that we have created for all the departments. We have provided them map navigation tools. They can build queries. They can carry out analysis. They can generate reports. They can attribute. They can update attributes. Attribute is something which is dynamic in nature, and it is not possible to freeze it at one particular day. So we will be giving complete authorization to the departments to update their attributes and take responsibility of that. Now, these are the few examples that how the 30 departments applications have been developed based on their functional requirement and to improve their efficiency and governance. This is the kind of analysis they can carry out. This is the geoportal which we have developed based on authorized person will be able to access this information on a secure network. This is the complete architecture that we have IP cameras. IP cameras will be sending live feed to monitoring centers. These IP cameras are of 5 kilometer range. They can do change detection up to 5 kilometers. You can do panning, zooming, and you can tilt them, rotate them up 360 degree, sitting in your monitoring center itself, and you can watch the city. Now, it can be very useful for monitoring and for other security related issues also. They will be all connected to a secure internet, to the control center. We have established a control center at Survey of India Push Bhavan, and there is a backup control center with the Government of Delhi at Delhi Secretariat. And all the departments will be accessing this information through the secure network. We will be maintaining this for 5 years. Thank you. I will just show one more 1 minute. This is what now the visualization, we are in the process of bringing out everything will be available online to all the departments like this. We have complete Delhi. We have 9 districts, 9 revenue districts. Of course, police districts are 12 and MCD zones are again 12, NDMC separate, cantonment board separate. This is how the complete vector data, whether it is underground, overground, everything is available in one server, and departments can access information. Not only about their own requirement, but they can visualize, like town planner, he needs to know what are the existing infrastructure available of Delhi Jal Board or the gas pipeline, or the fire department wants to know. We have already developed a application for them, and very actively they have been involved in finalization of the application. We have all underground utilities. In case of disaster, where is the wall, where is the reservoir, where is the water tank. Every information is available on this control center. Thank you.